Okay, welcome to another episode of Practical AI. My name's Jeff, and this is Peter. I'm the dumb guy. Peter's the smart guy. Today, we're going to talk about programming and whether AI and machine learning will replace programmers. Before we get into that, be sure to subscribe and like our sessions, and we will try to keep good notes near the comments section. So keep an eye out for that. Peter, you're a programmer, and I've been seeing a lot of stuff online about programmers being replaced by AI. What's your take on that?
My take on it is it's a useful tool, but it won't replace programmers for a couple of different reasons. All these models are trained on predominantly open source software. So stuff that is up on GitHub, that's up on the various kind of websites. And there's hundreds of millions of lines of code that's been trained on. But being an open source programmer, the honest truth is more than half of the code is garbage. So it's not the highest quality code that you'll ever see. And if we look at all software, all code, probably only about 5% be considered objectively high quality. And 95% of the code will be considered ugly, messy, or just downright hideous, which is kind of typical because when people are writing software, typically they're under some deadline, and time to market is usually more important than getting it pretty and beautiful. One of the people that you and I know, Dave Sear, likes to say, perfect code is the enemy of progress. Or the other thing he likes to say is shipping code is better than non-existent code. And as a result, a lot of these models don't produce great code.
Because the data set that they're looking at for code is poor or includes a lot of poor code.
Yeah. Yep.
Now, isn't there a couple of ways to improve that? Like one is you could slim down the data set to good code, which I think would probably take a lot of time of data scientists to know what it is. And and then isn't good code versus bad code sometimes dependent on either the purpose that it was built for or the context that it was built for?
Yep. Yeah. That's always the case. Like, even if you get perfect requirements today and you spend the time, days or weeks, or whatever, to come up with a good design, come up with a good kind of framework, good practices, and you build it correctly, in 6 months or a year, the requirements will probably change. Well, once that happens, you start changing the code, and your original pretty design starts to get bastardized.
You sort of get into a Rube Goldberg sort of phase, right? Where you're building lots of stuff.
Yep, exactly. Because like, let's say you get 10 sets of requirements and you built it to that. But then 6 months later, you're like, oh, actually, our customers want this completely different thing. Well, you built it with those 10 things in mind, and now maybe it's completely different 10 things. You have two options. You can completely write it from scratch, or you can change what you have to fit these 10 new requirements. And so quickly the code morphs and changes, and then after a few iterations, it starts looking kind of ugly.
Is there bad code that is just written poorly? Like even on the original system, the original requirements?
Yep, definitely.
And what is that? What defines, like, as someone who cares about good coding and sort of the ethics and the sort of the beauty of it, even, what is bad code right out of the gate? Like, how do you define it?
So I define it by, one, is the code well documented? Two, did the programmer or designer give good explanations for why they built it that way? Because there's no such thing as pretty code. If I gave the same code to 20 people, you're going to get probably 40 different opinions because everyone has a different way of thinking about how to solve a problem. And it's not always obvious what or why a piece of code was written the way it was written. So for me, the biggest thing is like when I write code, I try to document the design decisions, the business requirements, the business goals for why that piece of code was written that way. And I also add comments about, okay, we don't think we need these things at the moment, but that could change. And if it does, it'll impact the design this way. So I leave breadcrumbs for myself and for other people such that when they go back to change it, they're given hints as to like, oh, okay, that's why you chose these 4 different things.
Is well-documented code the norm, or is it the anomaly?
It's the exception.
Yeah. That's my understanding too. So in essence, you have a data set that's designed on either Rube Goldberg code or originally poorly documented code. And so now your AI, you're learning off of a data set that would produce this similar type of code. Now, would because I've never seen code well, I've seen code written and from a AI code. Does it also document? Would it also document the code? Is that an expectation?
Not really. So it kind of
Could
just
it?
It could. With enough training, you could.
Okay, so you could actually get code and the rationale behind the code,
Yeah, you could.
but you'd
So,
need a data set that was well documented code
yep.
for it to learn against, and that's even rarer than poor code, right?
Right. So the quote, the CEO of OpenAI, they have an army of people creating data to train the system. You would need to get an army of programmers to find good code, comment it all, create the data set, and then feed it to the model and train it.
And then let's say you could do that. Let's say you did that with Python.
Yeah.
Is that transferable to Java, or would you need Java code to do the same thing and C# and C and all of it?
Yep. For every language, you need a data set.
Okay. There's no way that the AI could figure out how to learn on Python and then just code in Java someday?
Um, it'll get probably half the way there. So like typically when Copilot came out last year, I tried it. I gave it a simple thing. I would say, write me a function that does this. And it would generate code. On first look, it looked okay. But then when you look closely and try to run it, it was a bug.
Mm.
So as a programmer, it's useful to generate kind of the rough outline of what you want. So you give it a description, like do this, write me a function that does this thing. It'll give you some code. And then you have to apply judgment, read it, understand it, decide, okay, no, there's actually 4 bugs here, or there's 1 bug here, or no, actually, I wouldn't do it that way. So as you do that, it can save you time. It can save you, like instead of having to, let's say you're using a new language. So let's say you program in Java and you're trying to learn JavaScript and you don't know the syntax for JavaScript to do what you want to do. Well, you could say, here's my Java example, translate it to JavaScript, so that it can do fairly well. Or if you're learning a new language, you can say, I want to do this thing, write this in JavaScript. It'll give you an example, but then you still have to actually read it and make sure that it works, and then modify any errors or mistakes that it's gotten.
I could see that as extremely useful as a new programmer or someone learning a new language. Sometimes it is nice to have context, something pre-built that you can kind of work with and screw up with. And now from a programmer perspective, is there a big difference in debugging code like that versus debugging something that you wrote? Or is it pretty much the debug is still the gold where you learn a lot,
Yep.
You learn just as much debugging something that AI wrote as something that you wrote?
So people have done experiments where they asked ChatGPT, write me code to do this thing. It spits out something and it's wrong. And then you can prompt it, say, well, I think this is not correct. Line 4 shouldn't be doing that. GPT will then respond with, oh, okay. Yeah, let me fix that. So if you spend the time, you tell it what's wrong with it, it'll eventually generate the correct code after hours or maybe a couple minutes. It depends on what you're trying to do. But people have done experiments where they give it like a set of tasks and say, write me code that does this. And they judge whether or not the code is accurate and whether it runs. More than half the time, it's not correct. But with some additional prompting, maybe 3 or 4 more steps, it'll correct that example and do a better job. But the question is, how many people are going to use that approach? They might start that way, but once they've got a fairly good grasp, it's easier for them to just write the code than sit there for 20 minutes trying to tell GPT, like, hey, you got it wrong, and this is why.
I'll do it myself.
Yeah.
Yeah. Okay, so where do you think this will end up? Like, let's just take the next 3 years. How will coding change, and what do you anticipate the coder will be doing 3 years from now that they weren't doing 3 years ago?
Well, it's still improving. So I think it'll get to the point where it'll give you correct code 90% of the time. So that'll be nice. If you just want to generate some piece of functionality and you don't want to spend a lot of time typing, and you think, okay, it would take me 10 minutes to write this, but it might take me 1 minute to ask GPT, it's worth a shot. If you get something useful, you can then modify it. So I think ultimately programmers will have to learn how to use ChatGPT and tools like this, so that if they're trying to tackle simple problems in a new language that they don't know or that they're not familiar with, they can kind of shortcut that and have it generate stuff for you.
Last question, and real brief, but are there concerns that most of the programmers work for a big company and they're working on a component of a business app that is specific to that business? So, are there concerns that that programmers might be putting in prompts that might be somewhat connected to intellectual property or intellectual ideas that the business would not want that prompt even to be presented to ChatGPT?
Yeah, so Apple recently told their employees to not use ChatGPT because they didn't want anything sensitive to get leaked to OpenAI. The other big issue is these models will spit out stuff that came from someplace else.
Mm.
And a lot of open source projects follow the the general public license, which says that you must cite the original author. Well, if you're using Copilot and it's spitting out code that it grabbed from some project that uses a license like GPL, well, now you're in trouble because they require you to cite it.
Yeah, that's a lawsuit waiting to happen, isn't it?
Yep. Yep.
Well, this is good. This will be a fun conversation to continue having over the years because you can already see that this could really help programmers, but it will open up some rules and some cans of worms along the way, and of course there's always going to be some sort of drawback, right? There's going to be some price to pay that we'll discover probably down the road that either programmers don't know how to do this anymore, or no one does this in programming like they used to, or whatever. But great conversation. Thanks again, Peter. This is good. We'll have more topics like this to go through. Be sure to subscribe and leave comments. Thanks again. Take care.